In this lesson, you will learn how to express solution sets in interval notation. So let's tie this to something you already know, inequalities. So the statement x is greater than negative 2 would include all real numbers greater than negative 2. You know to graph these on a number line with an open circle on negative 2, and you would shade all values or all real numbers that go to the right or are greater than negative 2. So how this is expressed in interval notation would be start with your starting point. It begins at negative 2 and your solutions go forever to the right or towards positive infinity. You are then either going to use parentheses or brackets to contain your interval, or a combination of the two. Well, since negative 2 is not actually part of the solution set, we use a parentheses. If it was part of the solution set, you would use a bracket. Now, infinity or negative infinity will always get a parentheses because you can't contain infinity. It keeps going forever and ever. The next one gives us a statement, all real numbers less than 5. Well, that would be x is less than 5 as an inequality. When we graph this on your number line, you would have negative 5, and once again you would have an open circle, but this time you'd be shading your values to the left. So this time, in interval notation, the numbers go forever towards negative infinity, and the highest they go is negative 5. Again, neither negative 5 nor negative infinity can be contained in the solution set, so both get parentheses. In our next statement, you are given a graph, which would be x is greater than or equal to 2, and this would include all numbers greater than or equal to 2 as a written statement. To express this solution set in interval notation, it begins at 2, goes infinitely to the right. This time, however, 2 is part of our solution set. To indicate that, we use a bracket, but again, infinity can never be contained, so it gets a parentheses. Try the next one on your own, pause, and then check your answer. So you can see that in interval notation, we have the interval from negative infinity to 7 with a parentheses and a bracket on the right. Now we'll look at slightly more complicated compound inequalities. So all real numbers between 0 and 4 would be 0 is less than x, which is less than 4, not including the two numbers, in other words. So on our number line, if I placed a 0 and a 4, and then the values between them would be open circles on each, and you would shade the region in between. So what that looks like in interval notation would be it includes from 0 to 4, but neither 0 nor 4 are included in the solution set, but all real numbers between them would be. Try the next one on your own. You can see the solution set on your screen. I suggest pausing the video and trying the next 3. The very last one might be a little tricky, but give it your best shot. So let's take a look at this last one together, now that you've checked your answers to the ones on the screen. All real numbers less than negative 7, so this would be x is less than negative 7, or, so I would actually have the word or written, x is greater than negative 3. So on a number line, that would look like this. We would have, let me order from least to greatest, negative 7 and 3. This would be an open circle and I shade to the left, and then an open circle and I shade to the right. So this is the first one that we've seen where there is a space in between. So the interval, in a sense, is broken. This is definitely an or a disjunction as it's known in mathematics. So the solution set includes negative infinity to negative 7, both with parentheses. And there is another part to this, which is negative 3 to positive infinity, both with parentheses, but the key is to use from your set notation to use the union symbol because the solution set is made up of both parts of these. So you could write them right next to each other typically. I just ran out of space in that little box there. So let's tie this together now with some knowledge you already have from previous courses, solving inequalities. So to solve this, we would add 1/6 to both sides, and that's going to result in x is less than 9/6, or x is less than 3/2, 3/2. Or we have another part to this. I'm going to subtract 10 from each side, which gives me negative 2x is less than or equal to negative 5. Then I divide by negative 2, which will cause me to flip the direction of my inequality symbol. So it would be x is greater than or equal to 5/2. So I'm going to graph my solution set on a number line, so that will help me to express my solution set in interval notation. So I'm going to close circle on the right because it's greater than or equal to. And now to write this solution set in interval notation, it would be negative infinity to positive 3/2, both with parentheses, union, bracket, because 5/2 is included, all the way to positive infinity. In this next one, I have a conjunction. I'm going to begin by multiplying by 3 because I want to get x alone in the middle. So I need to multiply by 3 here, here, and on the right. This would produce negative 9 is less than 5 minus 2x, which is less than or equal to 15. So now I'm going to subtract 5, which produces negative 14 is less than negative 2x, which is less than or equal to 10. Finally, I will divide by negative 2, which will cause me to reverse the direction of my inequality symbol because I'm dividing by a negative. So 7 is greater than x, which is greater than or equal to negative 5. Now, I don't like this because it's backwards to me, and I hope it looks backwards to you, so I'm going to rewrite this so that everything is from least to greatest. And to help you recognize what this will be in interval notation, you put negative 5 and 7 on your number line. You'd have a closed circle on negative 5, open on 7, and you would be shading the region in between. This makes it easy to see what your interval notation will be. It would be from negative 5 to 7. 7 is not included in the solution set, but negative 5 is. Now I'm going to solve a quadratic inequality and express its solution in interval notation. So there are several ways to do this. I'm going to do it by first finding the zeros of my quadratic inequality, treating it as if it were a quadratic equation. And to do that, I would do x plus 6, in other words, I'm factoring, times the quantity of x minus 6 is equal to 0, and that tells me by the zero product property that my two zeros are negative 6 or positive 6. Okay? So then what I do is I just sketch a number line and I place my zeros on that number line, negative 6 and 6. And what my inequality is saying is, where is x squared minus 36 greater than 0? Well, I know it's equal to 0 on negative 6 and positive 6. So since I just want to know where it's greater than 0, I'm going to put open circles, okay? If I wanted to know where it was equal to it, I would make it a closed circle here. And then what I'm going to do is I'm going to choose any value in each part of the interval, meaning a value over here, in between these two zeros, and to the right. So it doesn't matter what you pick, so pick something that's nice and easy. So to the left, something that's easy here would be negative 10. So if I plugged in negative 10, I would have negative 10 plus 6 times negative 10 minus 6. That would give me negative 4 times negative 16. And what do I know? That produces a positive answer. So to the left, it's going to be positive. And what do I want to know? Well, I want to know where is it greater than 0. So yes, I care about right here. It's positive. Now, if I choose a value in between, a nice easy number to pick will be 0. So if I plug in 0 into my function, so I'd have 0 plus 6 times 0 minus 6, and I would have a positive 6 times a negative 6 is going to produce negative 36. So it's going to be negative in between here. Well, again, I want to know where is this x squared minus 6 positive, or is it greater than 0? So solution set is not between them. And parabolas must come back up, so I know it's going to be over here, but just to illustrate again, I choose any value to the right. I'm going to choose positive 10. If I plug in positive 10 for x in both spots, that would give me 10 plus 6 would be 16 times 10 minus 6 is going to be 4, and a positive times a positive is a positive. I don't even really care what the number is, right? So now in interval notation, my solution set includes negative infinity to negative 6, union 6 to positive infinity. Now, if you were really good with parabolas in your last unit and you thought about the function where you have y equals x squared minus 36, and if we say, well, where is this greater than 0? What we're really saying is, where is this above the x-axis? Well, it would cross at negative 6 and positive 6, and since a is positive, it would open upward. So you know it drops below the x-axis between them, and it's above to the right of positive 6 and the left of negative 6. So it's kind of another way of realizing, oh, it's positive here, and negative in between. Okay, so let's do one more. Again, I begin by finding my zeros. So to do that, I factor and I get, let's see, x plus 5 and x minus 3 is less than or equal to 0. So my zeros here are going to be negative 5 or positive 3 would be where it crosses. So on a number line, I will put those two values. That is where it equals. And this time again, I'm interested in where is it equal to. So close circle for my zeros this time. Okay, they're going to be part of my solution set. And it's saying, where is it less than or equal to 0? So I'm really interested in, where is this negative? So one way to do this, again, is pick values. So something to the left of negative 5 would be like negative 10. If I plug in negative 10, I'd have negative 10 plus 5 times negative 10 minus 3. And I'm checking, is this negative or positive? This would be negative 5 times negative 13 is going to produce a positive answer. So it's going to be positive over here, and I want to know where is it negative. So if I choose something in between, nice easy value would be 0. So if I plug in 0, 0 plus 5 times 0 minus 3 is going to give me a positive times a negative, which is going to produce a negative answer. So there it is, it's negative in between. Again, if I choose something to the right over here, I'll pick 4. 4 is to the right. So 4 plus 5 times 4 minus 3 produces 9 times 1, that's positive, so it's positive over here. I'm interested, where is this negative is what the inequality says, or is it less than or equal to 0? So my solution set this time is in between. So in interval notation, it would be the solution set from negative 5 to 3, including negative 5 and 3. Again, if you were really good with your last unit, you would know this crosses at negative 5 and positive 3, and again, the parabola opens upward because the a value is positive. So I know that it's going to drop below the axis between those two values. Okay, as always, if you have any questions, please be sure to reach out to your facilitator.